If you think the sign of all terms is always positive, you are overlooking the sign rule in Notable Quotients. We begin this exercise with the goal of finding the third term of this given notable quotient. We recall the general formula to find any term which is plus or minus x raised to the n minus k times a raised to the k minus 1. To give it the standard form, we factor out 1/2 and rewrite the expression as x to the 12 minus 2 to the 4 over x cubed plus 2. We calculate the number of terms n, dividing the exponents 12 by 3, which gives us exactly 4. We apply the formula for the third term, substituting k with 3, obtaining x raised to the 4 minus 3 times 2 raised to the 3 minus 1. By subtracting the exponents, this expression simplifies directly to x times 2 squared. We take back the 1/2 we factored out at the beginning and multiply it by the x times 4 we just obtained. We simplify by taking half of 4 and happily obtain that our third term is 2x. Now, the question arises of exactly where this general formula we used to calculate term k comes from. To prove it, we write the full expansion of the quotient as a polynomial p of x with n terms. This expansion starts with x raised to the n minus 1, followed by minus x raised to the n minus 2 times a, and so on. We notice that these terms form a geometric progression where each term is multiplied by a constant ratio. We calculate that ratio dividing the second term by the first one, discovering that it is minus a over x. We clearly identify our first term, t1, which is x raised to the n minus 1. Our second term, t2, turns out to be minus x raised to the n minus 2 multiplied by a. And our third term, t3, follows the same pattern, being x raised to the n minus 3 multiplied by a squared. Generalizing this sequence, we deduce the formula for term k, where the sign depends directly on its position. Finally, we verify that for odd positions like 1, 3, and 5, the sign is positive, and for even positions, it is negative.